Welcome back everyone to Data Science for Everyone. Today we're going to be looking at data visualization with Seaborn. Let's get started. So Seaborn is a data visualization and statistical graphics library with Python, and it builds upon matplotlib as well as it integrates very, very well with pandas data structures. So Seaborn helps us actually explore, understand our data, and it has plotting functionality that operates on data frames and arrays. And it also we're able to do synaptic mappings and statistical aggregation with this, okay? It's also a data-oriented and a declarative API, okay, for data visualization. So first off, how do we actually get this? We import Seaborn as SNS. Now, one thing that I want to kind of mention with this, okay, this is as my title is dictating here, this is a crash course. Okay, I'm gonna move this down here. And as such, okay, I'm gonna go over a wide variety of topics. If you guys are interested in a specific topic more or less, let me know, and we'll work on that a little bit more at a later date. Okay, but only do that if you guys are interested. So next up, it has a ton of built-in data as well. So for example, it has the tips data set. And so we do this with the sns.load data set. And then we actually, if we look here at the parameters, we can actually click here on the data and I can show you guys. It has a ton of data sets that you guys can practice with whenever you need to. Okay, and so we'll actually use quite a few of these, and we'll probably even use some of these later on. So like, for example, I'll probably have a series just talking about statistics and doing Anscombe's quartet, as well as like the data source Rex type data sets. Now, the next thing we want to do once we've loaded in the data set, okay, is let's actually take a look at the data set. So tips.head, and here this data set is actually, whoops. Oh, it's because I didn't run that. So sorry, I got distracted. So you put in a string here with whatever the name was of the data set that you want. It will load that as a pandas data frame. And we can see here that this tips data set has total bill, it has the tip, it has the sex of the waiter or waitress, it has whether that was in a smoking section or not, it has a day, a time, and again, the time here, okay, is going to be like lunch or dinner. It's not going to be a specific date time object, and the size of the group. So if there was 2 people in the group, 4 people in the group, etc. Something that you would see on a sign-in sheet at a restaurant. Now, one thing that we want to do, okay, is let's just look and let's do, again, these examples are going to be pretty thick, okay, because I want to just show you guys the full functionality of what you can do with them. So let's do a relational plot, or we'll call it a rel plot. Now this takes in a couple different things. It takes in, you know what, let me do this so it's really clear. Data, and so then you give it the tips data set, and then I want to clear that out. I don't want this right now. There we go. And then you have your x-axis, and so here you put in a string. So I'm going to use, let me clean this up a little bit more. I want here, you know, and I'm going to actually do this the right way here. I like to actually do something like tips.columns. So I can actually see them and I can copy and paste. So I want total bill here. And then we want the relationship between that. Y is going to be the tip itself. And then we also want a column. So this column is actually is a facet grid, okay? And then we have hue. Hue is a meaning of color, so let's do smoker. And then style. Style is actually very useful. Style is, for example, doing dots or X's, something like that. And so we also want smoker for that. Again, there's some, everything's going to kind of double up here just because I want to show you guys the full extent. Oops. And one more that we have in here is size. Okay, and size, let's do it by the actual size of the group. So if we run this here, and again, this is I'm just showing you basically the full gambit of all of the attributes and arguments that you can use here with the relational plot. And what you can see here is along the x-axis we have total bill, on the y-axis we have tip. Okay, so how much the tip is. So again, we see that they are both upwardly correlated. Okay, they have a positive correlation, so that makes sense. Again, the larger the bill, usually the larger the tip. But then we also have some interesting things going on here, right? We see that there's actually a lunch time and a dinner time. Again, there's more people. Apparently more people come out to dinner at this restaurant. So then that's what we can see here. Now, again, it seems that there's maybe not a whole lot of correlation, for example, by the size of the group and the tip. Again, some here you see a little bit more, they're larger, and a lot of the smaller ones are down here. But then here, when we look at dinner time, it doesn't seem to make much difference whether they're not. And you don't see much difference in whether this being a smoker or not has any correlation either. This is a great way, again, when we look at data, to gather insight from our data is when we visualize the data. So let's go on to another quick example. And a lot of people like to talk about maybe the themes and everything else. I'm not going to talk about themes. I'm going to do just the bare bones today, just so you guys can get to plotting. I find people have a tendency to want to mess with the themes and make everything look really pretty, and they waste too much time on that and don't focus on the data. So focus on the data first and then make things look pretty. Okay, don't kill time otherwise. So I'm going to go through and I'm going to grab another data set here, and let's look at something like, what data set do I want? I want the dots data set. And we'll do also another rel plot. I like using the relational plots a lot because, again, we want to see the relationship between our data. So now, one thing that we have here, notice that this is actually a scatter plot. Okay, that's or a dot plot. Let me double check and see. I think, what do they actually call it? SNS dot rel plot here. Where's kind? Kind, yeah. So it's typical is a scatter. Okay, that's its default setting, is to do a dot plot or a scatter plot. Now, a lot of times when you have other types of data, for example, if you have a time metric on your x-axis, okay, you're usually going to want a line. So then we can change that to kind. And I can delete this now. Kind is equal to here. We want line. And then we can do something like x is equal to time. And you know what? You guys can't see what's on my other screen here, so let me do this. Dots dot columns, so you guys can see. Oh, it's because I haven't loaded it yet. Put that up here. So then we can actually take a look here at what's going on. Okay, so we want time on our x-axis. We want y to be the firing rate. The column is going to be a line, and the hue is going to be choice. Size is going to be coherence. Style is also going to be choice. Now, okay, so there's going to be a little bit of a harder thing to do here, but this is a little bit more of an advanced topic, but I think it's essential for you guys to know. And so in this example here, notice here that this x-axis is exactly the same. Now, that's not always the case. Sometimes you want to make sure that you separate the x-axes because you want them, there may be the variables are on completely different scales depending on the time of day, or in this instance, or maybe for their alignment, okay? It's going to be on two different scales. So then you would say facet, KWS, and this is basically for its arguments. Now it takes a dictionary, so I'm actually going to use the dict function in here, and you do share x is equal to false. So you want to turn off the shared x-axis functionality. And I'll show you the example, what's going on here, and I'll turn this facet off here in just a second. So now you can see here we have a time series analysis basically, and notice here this is the big difference. Okay, we do have our splits from our columns from our align being dots and sac. Now the y-axis is still the same. Okay, we can also turn off that share instead of, if you want to turn off the shared axis for y, you could turn it off by using share y is equal to false. You can turn that off as well depending. But here in this instance here, okay, for our times are different, okay, because they are off. And this is negative 600 seconds. This is negative 100 seconds. So you can see here that there is a difference between the x-axis. And again, I didn't dictate how I wanted my lines to look or anything else, and it just chose here dots and a solid blue line for our choices of T1 and T2. And then for size, for the lines, it chose the thickness of the line. You can change all of these types of settings as well. You can make the lines, their starting size thicker, thinner, instead of dots and dashes. Sometimes, for example, these colors are really bad. You can pick your own color schemes and everything else, but I'm going to leave that up to you guys to look up. If you guys are more interested, we can do a whole theme video or something later on, but again, I'm not going to worry about it too much. The size and style parameters, again, are both going to be used in the scatter plots as well as the line plots, and they affect the two visualizations differently, okay? So changing the marker symbol, for example, in the scatter plot like we did up here, okay? So like this style, not the style, yeah, the style here, okay? And it's going to change the symbols, okay? But it's going to change, and again, so here it's like, for example, it's a dot and an X. But whenever we have lines, it's going to be a solid line or a dotted line or a dot dash line, something of that sort. And that's going to be what the difference is in there. Now, the next type of thing that we want to look at, okay, is statistical estimation. Statistical estimation and error bars. Okay, and so this is, again, a lot of the times maybe we want to look at the average value of something or from other functions. Seaborn has functions that will automatically perform the statistics for us, okay? It makes life a lot easier when we're doing statistical estimation. That, again, it's necessary to answer specific questions that we want. So I'm going to grab the Fermi data set this time. And let me just go in and run that. And then I want dot columns so we can take a look. And then what are we going to do here? We're going to do time point on the x-axis, and we'll do region for the column. So SNS dot, we'll do a rel plot again. And again, I'm going to spend probably a lot of time on the relation plot because we always want to see the relationships between our data. And again, we'll go into some more advanced topics probably later on. So let's do data is equal to fMRI. Now, I have a tendency to always keep these labels, okay? I like, for my arguments, I always label my arguments. You don't have to, but then you have to memorize what order they're supposed to go in. So I would highly recommend you always keep everything like this, okay? Keep everything labeled so that it doesn't just go to the defaults. We want a line plot. Whoops. Line. Time point, y is equal to signal. Let's do our column. What do we want? We want region. And then hue is going to be event. And then style here is going to also be event. Now, a lot of times I have a tendency to match up hue and style. Okay, that's because whenever we see this, see here, hue and style, and same thing up here, hue and style are going to be the same. That's because that helps merge them into this order here, and it has a tendency to help bring out those visualizations, okay? In some other series and other courses, okay, we'll probably have a data visualization series later on. This is definitely the stuff that we would need to really get into and to really understand why we do these things. But for now, I want you guys just to be able to see what we can do with Seaborn. So let's run this. And so now what do we see here? We see like these are statistical estimations, all right? Now Seaborn is actually using a bootstrap method here to compute confidence intervals, and that's this gray, the shaded region on both sides. And again, this is also the error bars, okay? And this is representing the uncertainty of an estimation. Okay, so and that's very, very useful. So for example, I've seen some people run an analysis before, and all of a sudden everything in the whole page is grayed out, and that's because their error is so large it just encompasses the entire plot. So make sure it doesn't do that. Okay, that means that your model is probably doing fairly poorly. Okay, now other statistical estimation. Okay, we can also do descriptive statistics. We can even do linear regression, very basic linear regression using the LM plot. You know what, let's actually go on and do an LM plot as well. So, and just a linear model. Okay, now there are a couple different, so SNS LM plot, but we also have this reg plot as well. And I don't remember, maybe the LM plot is going to be depreciated. Let's see if it gives us a warning. And I'm going to use the tips data that we've already downloaded. Total bill, Y is going to be tips. Column is equal to time. Hue is equal to smoker. Tip. Let me run that one more time, clean that up. Okay, so what's nice about this is this technically ran several different regressions at a time, okay? It ran a linear regression for each of these lines is a different regression, so it ran 4 different regressions. So then you can see here, all right, that non-smokers, there's this crossing point where when the bill is up to a certain extent, they have a tendency to actually give more tips, and that's in both instances. So then this gives you an idea. You can maybe start to say, why is this the case? What would cause people to have this idea? Why would non-smokers give more money than smokers? Well, one, there's not a lot of observations in this lunchtime, but there's quite a few maybe in this dinner time. So maybe one thing that we could consider, let's think about a story for it, is that maybe smokers have a tendency to have a little bit different math going on in their head when it comes to eating. Okay, if you're maybe a pack a day smoker, again, I think now they're like $7 to $9 depending on where you are for a pack a day. So then they may be taking out that money out of their equation to say, oh, I need to save money for my smoking habit, so I'm not going to give as much money towards tips. Again, this is I'm not saying that at all. I'm just saying this could be a potential reason. It's based on looking at this graph, I need to investigate further. Okay, that's exactly what the purpose of data visualization is. It's to gain insight and to ask questions. Again, we never would have thought about this unless we had looked at this particular graphic. The next one is let's look at informative distributional summaries. Okay, so this is actually just dis plots. So this is talking about the normality of your data. Now this is, again, you have to know and go back into your statistics classes, okay? Think about your distributions. And this is to gain knowledge about the distributions of your variables. We're going to use the dis plot. okay? Not the dist plot, but the dis plot, okay? And this supports a ton of different visualizations. And again, these are all classical techniques like histograms, and again, some other computationally intensive approaches. So, for example, KDEs or kernel density estimations. And so let's do the tips data again. Tips equals total bill. Y is equal to, I don't want, now notice here, I have a tendency to do X and Y's. Since we're doing distributions, we only need one. We only have an X axis here, okay? But I also want to do a split for the column, so a facet on time. And I'm going to do kernel density estimation is equal to true. Okay, and this will give us, our nice histograms that we have here, okay, are the bars, and then the kernel density estimation is this nice smoothed curve in here. And we see here that both lunch and dinner have these little bit longer tails on them, so that the data is skewed in some way, shape, or form, and is definitely not a normal distribution. And so when you're doing your modeling or your predictive algorithms or anything like that, this is something that you would need to take into account, okay? Always take into account skew, kurtosis, etc. But again, it's just a nice way to be able to see what the distribution is of your data. Now another one let's do here. Let's look at calculating up, for example, empirical cumulative distribution functions. Okay, so your ECDFs. So sns.displot, and we want data is equal to tips here. We want kind. Here is going to be ECDF. X is going to be our total bill. Our column, again, we're going to keep it as time. Our hue, though, we're going to add in is smoker. And then we also want a rug plot at the bottom, and I'll talk about what a rug plot is here in just a second. So what we see here, again, there's, again, this cumulative distribution as it is, they are going up, okay, that's good. But what we see here then is this rug plot at the bottom is actually what I want you guys to see, as this shows each of the observations, where they actually are, okay? And you can see as they go, the steepness of this curve, okay, is where that rug plot is thickest, okay? That's what's giving it that upward momentum. Now, the next thing that we should probably talk about, okay, here we did a little bit of distributions. The next thing is categorical data, okay? Honestly, it's the bane of most people's existence sometimes when doing things, is categorical data. But again, there are a lot of beautiful and specialized plots that come with Seaborn, okay? And again, these these plots are, again, they're towards visualizing categorical data. Now we use, actually, you can have many different functions that you can use, but I have a tendency to want to just use the cat plot and then change the kind. So data here, again, I'm going to use the tips data. Kind is swarm. X, we want our day of the week. Y, we want total bill. Hue, here we want smoker. And we run this, we get this beautiful plot here, okay? Now this, you can think about this as some ways as, again, it's a tree, okay? We're doing basically a count method, even like a histogram. It's the old school histograms where you actually just dot them out. And you can see here something interesting comes up with the data, okay? One thing that would always stick out to me, okay? What type of business is only open Thursday, Friday, Saturday, Sunday? I find that very strange. So something that maybe comes up in my mind is, well, maybe this isn't a full data set, okay? So this starts to maybe make me question the viability of the data, okay? Or maybe it's not, but this is something that would lead me to want to investigate further. Why am I missing those days? Why is it predominantly smokers coming on a Friday? Okay, well, again, maybe it's a bar, okay? And so That's what they're doing. But again, most bars that I know are still open. Well, right now they're not open, but they're usually open several times more throughout the week. So another way to look at this, okay, and just one thing I'll say is notice that it still looks like that we have a nice distribution that we can kind of see here, but we can change this up just a little bit to have a distribution plot, okay? So we can use the violin plot. SNS cat plot. Here, data is equal to tips. Kind is equal to violin. X is going to be day. Y is going to be total bill. Hue is going to be smoker. And then here is going to be something very, very cool, okay? We're going to do split is equal to true. Now, when I run this, our violins are broken in half. We get to see on the right-hand side the distributions of the non-smokers, and on the left-hand side the distribution of the smokers. So then we can see each day how much these people were spending on the bills, each side, and then how their distributions are. So you see here that smokers, for example, I'll take this one on Friday, have a tendency to really spend a lot more money. They have these higher level bills than they do. Otherwise, they also have a lot of the lower level bills. But then most of the non-smokers are kind of bunched up here in the region. So if, and again, I don't know how many of you actually have worked at restaurants or anything, but I've worked at a lot of restaurants in the past. And depending on how this works, okay, sometimes this is a good thing, sometimes this is a bad thing. But people will pool their tips, okay? So maybe the higher tips are from smokers, okay? So then if someone's working in the smoking section, based on this, they may have higher tips than the rest. So if you guys pool your tips and you spread everything out, then maybe fair, but maybe not. Maybe then if you have people working in the smoking section and some people working in the non-smoking section, again, since there's a bit of a hazard working with smokers, then maybe that's their extra bonus, is getting the higher tips. Okay, so that's just something to think about as to why and how this is working, okay? And question the data. Because again, I would still think Friday looks really weird to me. Okay, so then I would ask the manager, is this really all the data? What's really going on here? Now, you can only see, again, we can see, for example, maybe we want to see the confidence intervals and look at something that's a little bit more nested. So let's look at a bar plot, cat plot here, and we want data is our tips data, kind is equal to bar, X is going to be day because we want our days of the week, Y is going to be the total bill again. And you can see here that I'm using the same data over and over and over again now because I'm wanting to dig deeper into the data. I want to start revealing a story about what's going on. Okay, data itself is about storytelling. You have to be able to know the narrative and write the narrative about what's going on. Now, I'm not saying make something up. You're not a novelist, okay? But what you are is you're a data detective. Try and get the best idea about what's going on in an environment without actually interacting with it. That's what it means to be a scientist, okay? So then you would need to ask more. So again, we see here, total bill, smokers have spend more money on average, okay, on all days except for Friday, okay? But they also, on Friday, as we saw here, they are still at the most extremes. So what does that mean, okay? I don't know, but we would maybe want to figure it out. Maybe you want, for example, okay, what if your bar or your restaurant wants to cut out smoking altogether? This is a way to see how that's going to happen, how it's going to affect your business. Maybe all of these smokers are going to go elsewhere. How is that going to hurt your business? How is it going to affect your bottom line? So that is always something that you can take into account as well. Now, something else that is very, very cool, okay, is we can start doing something very similar to these relational plots that we did before, but we can have a higher composition of the data using multivariate data sets, okay? We've only been looking at 2, maybe 3 examples at a time, so we can start doing more of joint plots, okay? So let's do something like composition, views onto multivariate data sets. Now, again, we want to combine multiple kinds of plots. Okay, that's the goal of this. Not composition, composite. I want composite. So composite here meaning we want to have multiple types of plots on a single graphic. Okay, so and that's what we're going to use with the joint plot. So let's play a little bit more and let's do penguins. Okay, penguins. So SNS dot load data set, and we want penguins. And then so SNS dot joint plot data is equal to our penguins. Penguins. X is going to be our flipper length in millimeters. Y is going to be our bill length in millimeters. And our hue is going to be the species of penguin. Again, who said we can't have fun with data? So now when we run this, the standard, okay, is going to be a scatter plot, and then you're going to have the kernel density functions for each of the species. Now this is great because it automatically color codes for you, okay? It color codes how we want our data to look. Let me see if I can zoom that in a little bit. So here we say that these, Adelie penguins here, they have a tendency to be probably a little bit smaller. They have smaller flippers. They have their bill length is also a little bit smaller. But then notice here they have their density. Okay, they have a very high density for the types they are. Okay, so again you can see that everywhere in here. You can look at all of the densities, etc. So this is very useful for when you want to look. And again, so bill length is you follow it straight across. Oops. You follow it straight across, okay? So that goes to here. So bill length goes to there, and this flipper length down here goes for up there. So then this becomes a very dense understanding of the data. Let's go through and do another one. Now, this next one, okay, I am going to give you a word of caution, okay? I'm going to do SNS.pairPlot. Now, for the love of all that is holy, make sure your data set's not too big, okay? This will crash your computer if you make it too big, or it may just go on forever and ever and ever because it is big and it does it on your entire data set. Okay, and you'll see even with this particular data set, it's going to take a little while. Okay, but again, don't worry too much about it. And again, here you can see it's quite big, but this is fantastic for when you run everything and you want to see the relationship between all of your data. Okay, we can change this, for example, that here we're doing the KDEs. We can change this to histograms. We can change all kinds of settings, but now we really get to see what is going on between each of the species based on that's their coloring mechanisms here, and how it pertains to their flipper length, their body mass, their bill, all of that. So along this line here, we have body mass in grams, flipper length in millimeters, bill length, and bill depth here, and then the same thing, okay? And that's why when they match up, we get the histograms or the KDEs. Let's see, how many? Hold on. Thank you guys so much for watching. If you like this, please comment, subscribe, and let me know how you guys like this content. Thank you very much. Bye-bye.